Hello all. So let us start off with today's lecture. We share the screen first. Okay. So hope the screen is visible. So before starting off with today's lecture, let us have a quick recap of what we discussed in the previous class, right? So we discussed about the naive bias classifier, right? Different types of naive bias algorithms that we have seen, right? And we also had a look on the experiment number 5 as well as experiment number 6, right? So all the both the experiment number 5 and experiment number 6 are based on the naive bias classifier. So we took an example and we discussed the code, the lab experiment number 5 and 6 both with an example each, and we saw the related output for that, right? So in today's session, we are going to start with the, let me, this syllabus. We are going to start off with the uh, lab experiment number 7. Let me zoom it in more. Yeah. So experiment number 5 and 6 deals with the naive Bayes classifier. Both in the first case, that is experiment number 5, we implemented the naive Bayes classifier with the training data set, right, .csv file, that is comma separated values file. We took a lot of examples. We saw the example of playing tennis, and then we also saw an example of a text classification, right? And also in the experiment number 6, which is again a naive Bayes classifier, we the experiment was to assume a set of documents that need to be classified. Right. So I hope you have at least given a try to write a program for this. But if you face any difficulty, you can reach me anytime, and soon I'll be making the program for this available right on our Google Classroom platform. So experiment number 6 was to assume a set of documents that need to be classified using the A-bias classifier model to perform the task using inbuilt Java classes. Right? So inbuilt Java classes or APIs you can use to write the program and to calculate the accuracy as well as precision. Right. So in today's lecture, we are going to see the Bayesian network. We are going to write a program to construct a Bayesian network, right? And as they have suggested here to consider the medical data, so we are going to use a data set which is from a medical background. We'll be taking up for a few examples also to understand, right? And use this model to demonstrate the diagnosis of heart patient, right? So we are going to use the medical data to demonstrate the diagnosis of the heart patient using standard heart disease data set. Right, so all the data set and all you can find it here in the standard repository, that is archive.ics.uci.edu, right, wherein you will have all the data sets for the machine learning lab. Right, so I'll make the link also available to you. Right. So with this, let's start off with the experiment number 7, right, which is to construct a Bayesian network considering medical data, right? And as they have suggested to use the medical data for the heart patient, we are going to use a standard heart disease data set, and we are going to use the Java or Python. So in this case, we'll be using Python machine learning library classes, right? So before going ahead to discuss this experiment number 7, to construct a Bayesian network, let us have a understanding of how can we form a Bayesian network, right? Let us first understand what do we mean by a Bayesian network. So talking about the same example, let's say we take a heart-related disease and we are going to discuss what can be the Bayesian network here that we can create. So let's say we have the data set for the heart disease. We have certain features, certain parameters here. Let's say pollution, right? Uh, that is nothing but one of the aspect to have a disease, which is let's say in this case, cancer disease to a particular patient. So we are going to assess few attributes here, few features here in the given the data set, and then we are going to see how much they are, what is the probability of a particular feature so that it can be the cause of that disease, right? So one can be, let's say, pollution, Second can be that patient can be a smoker, right? Then what we are going to use is we are going to produce the outcome, or you can say the result of infection or whatever the disease the particular patient is going through, right? So let's say we produce a X-ray for that, or also we want to produce a dysomnia for that particular patient, right? So let's give some statistic value to all these parameters so that we have some figure and we can use these figures to compute the probability, right? So let's say probability to to have a cancer for a particular patient because of pollution is, let's say, around 90, 0.90, right? This is the probability, right? And the probability of the patient being a smoker is 0.30, right? So we are going to use some more features. We are going to, of course, use these values to, find whether a particular patient has this disease because of what is the cause of it, right? So as you can see, there are some true and some false values here. So in order to understand that, let us get in detail how can we make use of this Bayesian network. But this is just for an example that what a Bayesian network would look like. Hope you recall from what we have discussed during the start of the module 4, right? When we had an overview of the Bayesian learning concept, right? So we discussed about the Bayesian network there also. We discussed about the acyclic graph, cyclic graph, then directed cyclic, uh, right? So undirected cyclic graph and so on. So these are the type of the Bayesian network that we can have. But here you can consider this one example for time being for the medical data, that is whether a particular patient has that heart related disease or not. Right. So this is the Bayesian network for, let's say, this is just an example that, let's say, this is the Bayesian network for lung cancer of a particular patient. Right. So what are the different attributes that we are going to encounter here? Right. So total we have 14 attributes that we are going to use. Number one is the age, right? Second is the gender or the sex of the patient. Then the other technical parameters which you don't have to worry much, but for example, cholesterol, the CP, test BPS, and other medical terms, you can say, and also the slope, the number, and etc. So these are different parameters which are related to the heart disease for a particular patient in case of, let's say, cancer. Right. So these are the different 14 parameter, 14 attributes. Right. So before showing you how exactly we are going to process it, let me show you what will be the output for these attributes as input. Right. So these 14 attributes will be the input, right, for our Bayesian network, right? And when we process these attributes, we compute the probability for all these values. Then the output we get is whether the patient has the heart disease, yes or no. That is, whether the patient has heart disease is zero, then it doesn't have that disease. Right? When the heart disease is one, let's say that patient is completely affected by that particular disease. Right. So this is the values that we have got. You can say that 0.5593 and 0.4407. So 55.9% that the heart there is the patient is not suffering from the heart disease, whereas 44% we got that the patient is suffering from heart disease. Right. So don't worry about these numbers right now. It depends on how better you have trained your model, and depending on that you might get these values different every time, so these value might change anyways. So now this is just an overview that what is the input for our experiment, what is the process, what actually that we'll be doing, and what is the output, right? So let us go a little more in depth and understand the minute details of this Bayesian network, right? So for that, let me first brief you about the algorithm itself, that is the Bayesian network, right? We also call it Bayesian belief network. So, what exactly is this Bayesian belief network, right? So, Bayesian belief network describes conditional independence. Now, this is important term. Independence is another important term. We will look into depth more. But the Bayesian belief network, it describes this conditional uh, independence among the subset of the variable, right? So what it does, it allows combining prior knowledge, right? So this prior knowledge, as I have been continuously repeating that in Bayesian learning, the one of the difficulty that uh, we face here in the Bayesian learning is that the prior knowledge, right, and the accuracy of that prior knowledge. So depending on the prior knowledge, we are going to compute the the posterior probability. Or we can say the current knowledge. So prior knowledge plays important role here, right? So since we are computing the probabilities, so we need to have some history of the data, or some prior data which can be used to process this. So how what does this Bayesian belief network does it? It describes conditional independence among the subset of the variable, allowing this prior knowledge about dependencies as well as independencies among the variable, right? Whatever the dependencies and independencies that we have been observed in the variable in the training data, right? So that is also called as Bayes net, right? Bayes nets. So now, what is this conditional independence? Right. So if I have to define conditional independence, it is, for example, let's say X is conditionally independent of Y. Right. So X, let's assume that this is how it can be defined, that let's say X is conditionally independent of Y given Z. Right. And if the uh, probability distribution governing the X is independent of the value of variable Y for the, of course, given value of Z, then we can define that conditional independence as this, right? Which is nothing but for all xi, yj, and zk, we have the conditional independent, the probability here, right? The probability distribution as this. So just to give an example, let's say thunder, right? Thunder is conditionally independent of rain. Thunder is conditionally independent of rain, given lightning, right? So I hope now you can able to relate now what is this uh, conditionally independent and what is the probability distribution, right? So this is again another example of having a Bayesian belief network. So let's say we have storm, we have bus, tour group, right? I'm just highlighting here. Then lightning, then campfire, thunder, and forest fire. So these are the different nodes in our Bayesian belief network, and we have the associated values with respect to these nodes. Right. So, as you can see, this is quite clear that this is actually a cyclic graph and as well as a directed graph. Right. So, as you can see, there is no cycle which is getting formed here in the network, right? And there is no, all the nodes have a directed graph associated to the other. This is a directed or cyclic graph. Right. So another example, if I have to show you, like this is, let's say, if I have to see the blood pressure of a particular patient, right? So the input is, let's say, whether that person done some kind of exercise or consumes smoke, right? And what will be the cholesterol level of that particular patient, right? So depending on that, we are going to compute the result, that is the outcome, which is whether it might get the heart attack or not. Right. So this is the example again, which I have posted here. That is the Bayesian network for the lung cancer problem. Right. So this is the same example. Right. So let's say let's discuss one by one that how are we going to construct this complete Bayesian network. Now you have the theoretical background of how is this a Bayesian network. What is this Bayesian network and what are the different important aspects and attributes in this Bayesian network? Let us go ahead and step by step see what are the different approaches to have this Bayesian network uh, and how to construct it. Right. So we'll take the same example for our medical data itself, since the experiment, the title of the experiment is quite clear that we have to make use of medical data. Right. So we'll construct a Bayesian network considering the medical data itself. Right. So first thing is to define the structure. Right. Structure of what? Structure which consists of nodes, some edges. Right. So we need to define the structure of this complete network. So we'll be starting off with defining the network structure, right? And how do we do that? So for that we have inbuilt models available, and also modules which we have to import it, right? So we are going to import it from the pgm dot models, and we are going to import Bayesian model, right? So once we have that, we are going to populate our data with the we are going to create a list and populate the list with some attributes, some values, yes, right? So let's say cancer model, which has the which is a kind of a list that we are going to create here, right? And Bayesian model, which has the values: pollution, cancer, smoker, cancer, again cancer, X-ray, cancer, uh, dysphonia. So these are the you can say the edges that we are trying to create here, the directions from pollution to cancer, smoker to cancer, and so on, right? And then we are going to simply create you know the different other functions which will be using. So the second step is to creation of the conditional probability table. Right. Once we have the data, we are going to create the conditional probability table, defining the different parameters. Right, all the different parameters, that is pollution, then yeah, pollution, then smoker, cancer, right, X-ray, and dysphonia. So once we have this, all the conditional probability table, right? So now we are now ready to associate these terms with the other conditional probabilities. So once we have these terms ready, associating the conditional probabilities with the Bayesian network, and in this we are going to associating the parameters with the model structure. And how do we do that? We are going to check if these CPDs, right? These CPDs are valid for the model or not. Right? CPD is the conditional probability. Right? Conditional probability, are they valid for this model or not? So for that, we are going to use the cancer model dot check underscore model function, which we have already defined here. Right? Right. So once we create these simple queries in the network, right? Once we have this network, we determine the local independencies, right? So here simply I'm going to define the local independencies for all the attributes here, that is X-ray, pollution, smoker, dyspnea, and cancer, right? So once we have the local independencies, then we can inference with the Bayesian network. Right. Now, doing exact inference using variable elimination. We are going to use the variable elimination to inference with the Bayesian network. Right. So for that, we have to import the variable elimination, right, and then compute the probability of given smoke, right, and also compute the probability of bronch given smoke, right. So once we compute the probability for all the variables, right? Please note here that this, right, from here to here, we are going to compute the probability of the bronchitis given the smoke as the input, right? So once we have this, the next is to diagnose for the patient for the data set, right? Whatever the data set that we are going to import, right? So diagnosis of the heart patient, let's say using a standard heart disease data set, and I've already given you the link for the data set where you can get the data set downloaded, right? So first thing first, we have to import the NumPy as NP and all the important libraries that we are going to use, that like URL, lib.request, matplot, lib.pyplot, then cborn, sklearn, and pandas. right? So I hope MATLAB and these things, you know why we're using this. For example, MATLAB is used to visualize graph, or you can say to visualize the output that we process. Right? Okay. So importing the data set you can do using this website, that is archive.ics.uci.edu. Right? So this you can get, and the data set that I am using here is the processed Hungarian data. Right? So this is the data set from the Hungary for the heart disease related patients. Right? So I just put up the URL here. Right? You can simply download it. Maybe I'll make it available in the video and also in the Google Classroom uh, also. Right? Okay, so once we have that, now let us go and define all the attributes, right? Hope you remember the 14 attributes that we discussed. That is, let's say, let's label them as name. And we are going to create the list of all these attributes, right? So which has age, sex, CP, test BPS, cholesterol, FPS, and all the other parameters to detect whether the patient has the disease or no. And then ultimately our main attribute, that is heart disease, which is 0 or 1 or yes or no, right? So yeah, once we have these details ready with us, we can start modeling our data, right? Modeling our heart disease data. So for that, again, we have to was invoke the Bayesian model, which we have already defined before. So we are going to simply invoke it here, right? And this is, as you can see, it is a list, right? And once we learn the CPD using this, you know, once we invoke this Bayesian model, next is to find the maximum likelihood, right? Maximum likelihood hypothesis for the given set, right? So we are going to compute the maximum likelihood estimators here for the data set that we have for the heart disease, right? So yeah, so model dot get CPDS age, then model dot get CPDS cholesterol, model dot get CPDS sex, and model dot get independence. So all the independencies will also be invoked here, right? And which will be helpful for us to check the inferencing with the Bayesian network. And how do we do that? Like I mentioned, we'll be uh, inferencing using the variable elimination. Right. So once we have the heart disease inferred, we are going to invoke the variable elimination model. Right. And then ultimately we are going to be computing the probability of the bronch given the smoke. But so once you execute these uh, set of codes, the output looks something like this. That is, let's say when you try to print the heart disease, then the output looks something like this. This is the let's say heart disease. Zero denotes that the patient doesn't have the heart that particular heart disease. One denotes yes, it has. So you can see 63%. That is, you can say 0.633, that is nearly 63%, that the patient doesn't suffer from the heart disease, and 36% you can say that the patient is suffering. So though it will not be 100% accurate, but the more data you train the model with, and the type of the data, of course, you train, and the more number of times you train the model will define your overall accuracy, right? So when the heart disease is zero, that is denotes that the person is not suffering from the particular heart disease, and when it is one, the patient is suffering. So this is the Y value for that heart disease is what we have computed here. So this is the output. Right. So not necessary with respect to this particular problem, but you can take any medical data, right, related to, of course, heart disease, which is available from the given link, and you can process that particular data set to produce your own output. Right. So you can give a try first, but if you face any difficulty in trying this thing, you can reach me out anytime, right? And maybe next lecture, I will provide you with the other details of the this particular experiment. Right. So till that time, give a try for this, and let me see if, if you can execute it. And if you face any difficulty, you can ask me. Right. So you can ask me anywhere in the Google Classroom itself, or you can put it in the description in the video. Right. So this is about the Bayesian network and the heart-related disease data set and the different steps. How do we compute? How do we start off with uh, writing the code to construct a Bayesian network? Right. So with this, I shall conclude the lecture, and we shall see that in the next lecture that how many of you get the output for this. Right. So that's all for today's lecture. We shall conclude. Thank you.